Auzu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. Projection of points. As you already know that point is a geometrical entity having no dimension and indefinite directions. The actual point in space is annotated as an uppercase letter. So, like any geometrical entity that would carry its own name, for example, a line would carry its own name, for example, line AB, line BC, line CD, etc., etc., or other geometrical shapes, for example, rectangle ABCD, like this. So the point will also carry its own name. For example, point A, point B, point C, point D, etc., etc. And the name of the point should be annotated or written with an uppercase letter like this. Or for point B, like this. The front view is annotated as a lowercase letter with a prime, and the top view as a lowercase letter without a prime. So, in orthographic projection, we will be dealing with the views or the projections of a geometrical entity, and for that, we will be at least drawing two views, that is the front view and the top view. We can also draw its side view as well, but for now, you only consider two views, that is the front view and the top view. So, the front view of point A should be annotated with A prime, and its top view would be annotated as A. Similarly for B, B dash and B. The intersection of two principal planes, that is the horizontal plane, also abbreviated as HP, and the vertical plane or VP, is a straight line known as the reference line and shall be annotated as the XY line. So let us examine the two principal planes of projections. We can have the third one as well for the that would be called a profile plane or the side plane. But for now, let's examine the two planes. So we in three-dimensional space for an entity lying anywhere in the three-dimensional space, we can refer that entity with these reference planes, as well as we will be drawing the the views of that entity on these principal planes. So generally we will be having two principal planes of projection, that is the horizontal plane and the vertical plane. You can assume or reckon the floor of your room as a horizontal plane, and also you can reckon the wall of your room as the vertical plane. So any drawing entity that you would want to draw its views would be lying somewhere in the three-dimensional space, so you can refer it from these two reference planes. So you can see that the two principal planes of projections would meet at a common line, or you can say that they would intersect, and the intersection line or the common line would be called the XY reference line. It is called XY reference line because we will be referring things which would be relative to the horizontal plane, or its relative position to the horizontal plane can be referred from the XY reference line, as well as its relative position with respect to the vertical plane will also be referred from this XY reference line. So collectively it is called the XY reference line because we will be oftenly referring to an entity with respect to these two reference planes. For example, you can see that a point A is lying in this region or this area. So you can see that this is the area which is above the horizontal plane and in front of the vertical plane. So this point A could be referred from the XY reference line. You can see that this point will have at least two views. You can have more than two views. Depends on the drawing entity. So the drawing entity, for example, for a point, only one view will be sufficient because the other views will be similar to the first. For example, if you look at this point from this direction, for example, if this is the observer and this is the point, so its image, for example, you can reckon this beam of light emitting from the observer, and it would, for example, draw an image of this point on the vertical plane at this location. So in to the point A or to the drawing entity, and also if the projector, this can be called as the projector, must also be perpendicular to the vertical plane. So you can see that its image would be drawn on the vertical plane, and this would be called its top front view, as you are looking at it from the front, from this side. You can also look at it from the other side as well. Then the observer would be, for example, would be here, and the reference plane or the projection plane, the vertical plane would be in between the observer and the point. In this case, the point is between the observer and the plane of projection. So always the front view would be drawn on the vertical plane, and the front view would be annotated with a prime on it and with a smaller case letter. Similarly, looking at this point from the top or from the bottom, you can also look at it from the bottom as well. So there would be no difference. So, for example, if the observer is looking at this point from the above, you can see that the ray that is emitting from the observer and striking the point would draw the image of this point or the view of this point at the horizontal plane. This is called the top view. So always the top view would be formed at the horizontal plane, and that top view would be annotated with a smaller case letter but without a prime on it. So you have seen that for projection we will be having two principal planes of projection, that is the horizontal plane and the vertical plane. And you can also see that these two principal planes of projection are also working as a reference plane, because if you refer to this point A, so you will say that the point A is, for example, 10 millimeter above the horizontal plane and 15 millimeter in front of the vertical plane. So these two planes would be used for references as well as for the projections. And you can see that the common line that these two planes would form will be called the XY reference line, because the same line could be used for referring anything with respect to the horizontal plane or X, and also anything with respect to the vertical plane or Y can be referred from this XY reference line. So that is why it is called the XY reference line. So with respect to the horizontal plane and the vertical plane, we can have different positions relative to the two planes of references. A point can be situated anywhere in the three-dimensional space relative to the two planes of projection. The point can be either above, below, or within the horizontal plane. So, for example, if we draw a line, a straight line, and call it a horizontal plane, so anything with respect to this horizontal plane can have three positions. Anything can be above the horizontal plane, and anything can be within the horizontal plane, and anything can be below the horizontal. So these will be the three references with respect to the horizontal plane, or relative position with respect to the horizontal plane can be these three. With respect to the vertical plane, anything can be in front of the vertical plane, anything can be within the vertical plane, and anything can be behind the vertical plane. So with respect to the vertical plane, we can have these references: in front of the vertical plane, within the vertical plane, and behind the vertical plane. So overall, we can have nine positions. For example, if this is the horizontal plane and if this is the vertical plane, so we can have these positions: in front of the vertical plane, above the horizontal plane, within the vertical plane, above the horizontal plane, above the horizontal plane, behind the vertical plane, within the horizontal plane, in front of the vertical plane, within the horizontal plane, within the vertical plane, within the horizontal plane, and behind the vertical plane. Also, behind the below the horizontal plane, in front of the vertical plane, below the horizontal plane, within the vertical plane, below the horizontal plane, and behind the vertical plane. So we can have these nine positions: one, two, three, four, five, six, seven, eight, and nine positions with respect to these two principal planes of projections. So, with respect to horizontal plane, we can have above, below, or within. This is the case. We can have above the horizontal plane, within the horizontal plane, and below the horizontal plane. With respect to the vertical plane, we can have in front of the vertical plane, within the vertical plane, and behind the vertical plane. So, collectively, we can have nine possible positions with respect to the two principal planes of projection. Nine possible positions with respect to the two principal planes of projection. The first position is above the horizontal plane and in front of the vertical plane. So let me draw the first is when the point is above the horizontal plane and in front of the vertical plane. So you can see that basically these two planes of projection form four quadrant. You can see one, two, three, four. So according to the statement, above the horizontal plane, now this point is above the horizontal plane and in front of the vertical plane. So it is lying basically in the first quadrant. It is lying in the first quadrant. And when we draw its projections, so the projections would be according to the first angle projection. The projection drawn would be according to the first angle projection. We will see that what's the difference between the first angle projection and the third angle projection. For example, now this is the case for the point to be above the horizontal plane and in front of the vertical plane. So the point A is basically lying in the first quadrant. Now if we draw its views, that is the front view and the top view. So for the front view, as I have said, looking at the point from this side, or you can also look at it from this side. But in that case, the plane of projection would be in between the observer and the point. This plane of projection can be assumed as a transparent medium, and you can see that the projector or the ray emitting from the observer and striking this point A would cut the vertical plane at this position, or its image will exactly be formed at this position. So similar to if you draw it from this side. Similarly, if you look at it, point A from this side, so the projector would draw its projection on the vertical plane at the similar position. So there would be no difference if you are drawing, if you are looking at the point from the front side or from the back side. So that would not make any difference. The projection would come at the same position, and always the front view would be drawn at the vertical plane. So you can see that in this case the front view has been drawn at the vertical plane and above the XY reference line. For the top view, you will look at it from the above or you can also look at it from the bottom as well. So if you are looking at it from the above, so this projector or ray would project the image of this point on the horizontal plane at this position. Now, to draw it on the sheet, the method in vogue is that you will have to rotate the horizontal plane about 90 degree. So when you rotate it, about 90 degree, so you can see that it would come in exact alignment with the front view. That is why we rotate it in order to bring it in alignment with the front view. That would make the two views to be efficiently drawn, as most of the common dimensions would be only drawn once, and this would remove or eliminate the redundancy in your drawing sheet and would make your drawing sheet more efficient. So when you rotate, for example, this about 90 degree, I have, so this point would come to this position, or the horizontal plane would overlap or would merge with the vertical plane, and you can see that this point would be rotated to this position in exact alignment with the front view. So on your sheet you will be only drawing the XY reference line, and you can see that the front view of this point A is coming or being drawn at the vertical plane, and you can see that the front view is being drawn above the XY reference line. So we will only be drawing the XY reference line. Now the relative position of the two views, that is the front view and the top view, with respect to the XY reference line will be drawn according to its position. So the front view is coming on the vertical plane and above the XY reference line. So we would draw the front view. For example, if the point A was 10 millimeter above the horizontal plane, so its front view will also be drawn 10 millimeter above the XY reference line, and we would annotate it with A dash. Now for the top view, as I told you, looking at it from the top or from the bottom, its image would be drawn on the horizontal plane. Now rotating the horizontal plane about 90 degree in order to merge it with the vertical plane or to align it, the top view with the front view. So the top view you can see would be placed somewhere at this position on the vertical plane, means below the XY reference line. So in actually you will be drawing these dotted lines or projectors, and you can see that the top view would be drawn in exact alignment with the front view below the XY reference line. So this is called the first angle projection. In the first angle projection, if the point is lying in the first quadrant, so its front view will always be above the XY reference line or within the XY reference line. And its top view will always be below the XY reference line or within the XY reference line. So this type of projection or method of projection is called first angle projection, in which the front view is coming above the top view. You can see that the front view can be recognized with its prime on it. So we have drawn two views of the point A, that is the front view, which is coming above the XY reference line, and its top view, which is coming below the XY reference line. So this method of projection would be called first angle projection. The second, above the horizontal plane and behind the vertical plane. So the second case is above the horizontal plane and behind the vertical plane. Now you can see that the point A is lying still above the horizontal plane, but this time it is behind the vertical plane and is lying in the second quadrant. So you can see that if you want to draw its views by looking at it from this side or from this side, its image or front view will always be drawn at the vertical plane. Remember that the front view will always be drawn at the vertical plane. So you can see in this case, if we want to draw its views, so we will only draw the XY reference line. We will not draw these two planes. These two planes are for your understanding that you must depict the exact orientation of your point and then how to draw it on your drawing sheet. So first of all, you have drawn XY reference line. Now, as the point is above the horizontal plane, so its front view is also coming above the XY reference line on the vertical plane. So its front view would be drawn above the XY reference line. Now this distance, how much above the XY reference line? This much distance. Now this much distance is not given. We will be given the distance above the horizontal plane. So for example, if this distance is 10 millimeter above the horizontal plane, so its front view will also be coming 10 millimeter above the XY reference line. You can see it from here because we have assumed that the projector must be perpendicular to the vertical plane and must also be parallel to the projector. In this case, we are having only one projector. So its front view has been drawn above the XY reference. Now for the top view, for example, if you also want to draw its top view, so you will be looking at it at this point from the top or from the bottom, for example, from somewhere here. In both of the cases, its top view would be formed at the horizontal plane. Remember, always the top view would be formed at the horizontal plane. So you can see that the top view would be formed. Now, the method in vogue is that you will rotate the horizontal plane about 90 degrees once the top view has formed. So, for example, rotating it clockwise as we have done it. So, this quadrant would merge below the XY reference line and this one would come and would merge the vertical plane above the XY reference line. So the top view would be coming somewhere at the vertical plane at this position. If the point is equidistant, means that if the point is equally 10 millimeter above the horizontal plane and 10 millimeter behind the vertical plane, because the location or the position of the top view depends on the distance from the vertical plane, how much it is behind the vertical plane. So if for example the point is equidistant, means that the point, if the point is 10 millimeter above the horizontal plane and 10 millimeter behind the vertical plane, so their front view, so its front view and top view would overlap. So there would be a chance that the top view could overlap with the front view. So in that case, you will be writing A comma A dash. if both of the views overlap. But if both of the views, if the point is not equidistant, for example, if it is 10 millimeter above the horizontal plane and 15 millimeter behind the vertical plane, so its top view would be coming above the front view somewhere here. Now, in either cases, if the point is lying in the second quadrant, so its front view will always come above the XY reference line as well as its top view will also come above the XY reference line. So both of the views, that is the front view and the top view, would be forming or would be drawn above the XY reference line. So this method will be called the second angle of projection. In second angle of projection, both the front view and the top view would be coming above the XY reference line. Now the third case would be above the horizontal plane and within the vertical plane. Above the horizontal plane and within the vertical plane. So this is the case. The point is still above the horizontal plane, but this time it is within the vertical plane. So you can see that looking at this point from this side or from the rear side, its front view will be formed at the vertical plane. As always, the front view is formed at the vertical plane. But you can see that it is still above the XY reference line. So when you draw it on your drawing sheet, so you will draw the XY reference line and you will draw the front view above the XY reference. How much? That much to which the A was above the horizontal plane. So its front view again is coming above the XY reference line. And for the top view, if you want to draw the top view, so you will be looking at it from the above or from below, from bottom. Its top view would be formed exactly on the horizontal plane at this location. So you can see that a rotation, if once the top view is formed on the horizontal plane, so you would rotate the horizontal plane. But the rotation would not make or would not change the position of the point as it is lying on the XY reference line. So the rotation would not change its position because there is no distance to be rotated. So its top view would be lying or coming on the XY reference line. So this type of projection, or you can see that this point location is common. It is at the boundary of the first quadrant and the second quadrant. So you can take it with the first quadrant or with the second quadrant. In either case, its front view will be above the XY reference line and its top view will be within the XY reference line. So this can be reckoned as first angle projection or second angle projection. So when the point is at the boundary of the first quadrant and the second quadrant, so the angle of projection that can be used will be either first angle or second angle, and by using both or any of them would give you the same result. So above the horizontal plane, within the vertical plane, so it is basically boundary of first and second angle or boundary of first and second quadrant below the horizontal plane and within the vertical plane. So we have seen the cases are the point above the horizontal plane. So if a point is above the horizontal plane, its front view is always drawn above the XY reference line. We have seen in all the cases, front view was coming above the XY reference line when the point was above the horizontal plane. Now, the fourth case is below the horizontal plane and in front of the vertical plane. Below the horizontal plane and in front of the vertical plane. So you can see that the point now, the point A is lying below the horizontal plane and in front of the vertical plane, basically in the fourth quadrant. In the fourth quadrant. So looking at this point from this side or from the rear side, its image would be drawn at the vertical plane. As always, the front view is drawn at the vertical plane. So its front view would be drawn at the vertical plane, but look at it, it is coming below the XY reference line. So when you draw XY reference line, so its front view will be coming below the XY reference line. How much below? That much which the point A is below the horizontal plane. For example, if the point A is 10 millimeter below the horizontal plane, so its front view will also be coming 10 millimeter below the XY reference line and will be annotated with A prime. Now for the top view, looking at it from above or from the bottom, its top view will be formed exactly at this position. Now after getting the top view at the horizontal plane, the method in vogue is to rotate the horizontal plane about 90 degree so that the horizontal plane merge with the vertical plane. So you can see that the top view would be placed somewhere here on the vertical plane, but below the XY reference line. So its top view will come below the XY reference. Now, if the point is equidistant from both the plane, for example, if the point is 10 millimeter below the horizontal plane and also the point is 10 millimeter in front of the vertical plane, so in that case, the two views could overlap. That is why the fourth angle of projection, or as we had seen it in the second angle of projection, that there was a chance of overlapping as well. So that is why the second angle of projection and the fourth angle of projection are discarded and are not being used in engineering drawing because of this overlapping. This overlapping could happen. So, for example, we are considering a simpler case of point. If we consider other geometries, then their front view and top view would differ from one another. And in that case, if the two views overlap, so you will get a distorted sort of uh, front view and the top view, and nobody would understand. So that is why the second angle of projection and the fourth angle of projection are not being used because of the chances of overlapping of the front view and the top view. So, for example, if the point is not equidistant, then the top view could come below the front view or somewhat above the front view, but will always be below the XY reference line. So, this is how. So, it will be the case of the fourth angle projection. If the point will be lying in the fourth quadrant, its front view and top view both will come below the XY reference line. In second angle, both were coming above the XY reference line. And in fourth, both are coming below the XY reference line. In first, the front view would be above the XY reference line and the top view would be below the XY reference line. Now, below the horizontal plane and behind the vertical plane. Below the horizontal plane and behind the vertical plane. So this is the case. Now the point is lying in the third quadrant. Below the horizontal plane and behind the vertical plane. So this is the case of third angle projection. The point is lying in the third quadrant. Now in the third angle projection, looking at this point A from this side or from this side, its image or projection would be drawn on the vertical plane, as the front view will always be drawn on the vertical plane. So look at this. As the point is below the horizontal plane, so its front view is also coming below the XY reference line. XY reference line. So its front view is coming below the XY reference line. Now for the top view, looking at it from the above or from below, its top view would be formed on the horizontal plane at this position. And when you rotate the horizontal plane about 90 degree, so you can see that this top view would come somewhere at this position on the vertical plane, means above the XY reference line. So its top view would be in exact alignment with the front view and it would be somewhere above the XY reference line. So in the third angle projection, which is opposite to the first angle projection, in third angle projection, the front view would be below the top view. And the first angle, the front view was above the top view. So this is the difference between the first angle and the third angle projection. So you can see that in this projection method, there is no danger of overlapping, as was the case with the first angle projection. So the first angle projection and the third angle projection are being used worldwide because they the views in these methods or these angle of projection doesn't overlap. You can see that the top view is coming above the front view in this case in the third angle projection. In the first angle projection, the front view would be at the top and the top view would be below the front view. So this is the case of the third angle projection. Below the horizontal plane and within the vertical plane. Below the horizontal plane and within the vertical plane. So this is the case. Point A is still below the horizontal plane, but is within the vertical plane. So for its front view, looking at it from this side or from the rear side, its front view will be drawn exactly at this position on the vertical plane. If you draw the XY reference line, so you can see that the front view is being drawn at the vertical plane but is below the XY reference line. So its front view will be, as the point is below the horizontal plane, so its front view is also below the XY reference line. It is. For the top view, looking at this point from the top or from the bottom, its projection would be formed on the horizontal plane exactly at this position. And rotation would not change its position. So its top view would be formed within the XY reference line. So, if the point is below the horizontal plane, its front view is coming below the XY reference line. And as the point is within the vertical plane, so its top view is coming within the XY reference line. So, this is the case when the point is lying at the boundary of the third and the fourth quadrant. So, you can reckon or say that this is the case for the third angle as well as for the fourth angle of projection. And both would give you the same answer. So either to draw it according to the third angle or according to the fourth angle, and the result would be the same. So as far as the point is at the boundary of the third and the fourth angle of projection, so you can use any of the two methods and would the result would be the same. So if a point is below the horizontal plane, its front view is always below XY reference line. So you have seen that the position of the front view is dependent on its position relative to the horizontal plane. If the point is above the horizontal plane, its front view is also coming above the XY reference line. If the point is below the horizontal plane, its front view is also coming below the XY reference line. If the point is within the horizontal plane, its front view is also coming below the within the XY reference line. So point within the horizontal plane and in front of the vertical plane. So now the case is for within the horizontal plane. We have seen so far three cases for above the horizontal plane, three cases for below the horizontal plane, and now three cases for within the horizontal plane. So this point A is within the horizontal plane or lying in the horizontal plane and is in front of the vertical plane. So for drawing its front view, looking at it from this side or from the rear side, its front view or its image would be drawn exactly at this position on the vertical plane. So its front view is being drawn and at the XY reference line. Sorry, dash. And for the top view, you can see looking at it from the above or from below, its top view would be formed exactly at this position on the horizontal plane, and after rotating the horizontal plane, so the top view would come below the XY reference line somewhere here. So if the point is within the horizontal plane, its front view is also coming within the XY reference line. If the point is behind the vertical plane and still within the horizontal plane, so its front view is again coming at this position within the XY reference line. And you can see for the top view, look at it from the top or from the bottom, its top view would be formed at the horizontal plane, and after rotating the horizontal plane about 90-degree clockwise, so this point would be rotated to this position on the vertical plane above the XY reference. So the front view is still coming within the XY reference line and a top view above the XY reference. Now this is the third position, that is within the horizontal plane and within the vertical. So this is the position that this point can be reckoned with any of the four quadrants. The previous one can be dealt because it is at the boundary of the second and third quadrant, so it can be reckoned as is can be reckoned as within the second quadrant and can be drawn using second angle of projection, or if we consider it to be in the third quadrant, so we will use the third angle of projection, but the result would be the same. So for this point, as it is lying within the horizontal plane and within the vertical plane, so it is basically at the boundary of all quadrants. So you can see for drawing its front view, looking at it from this side or from the rear side, its front view would be formed on the vertical plane at this position, means at the XY reference line. And for its top view, looking at it from the above or from below, its top view would again be formed at the horizontal plane, but at exactly at this position. So both of the front view and the top view would be formed at the XY reference line. In case if the point is within the horizontal plane and within the vertical plane. So if a point is within the horizontal plane, its front view is always in XY reference line. So the position of the front view of a point with respect to the XY line is dependent on its position with respect to the horizontal plane. The distance of the front view of the point from the XY line is the same as the distance of the point from the horizontal plane. So if the point is, for example, 10 millimeter above the horizontal plane, so its front view will be coming 10 millimeter above the XY reference line. And if the point is 10 millimeter below the horizontal plane, so its front view will also be 10 millimeter below the XY reference line. If the point is within the horizontal plane, so the front view will also be coming within the XY reference line. Now, these cases have been discussed within the HP and within the vertical plane. So the 9 possible positions that we have discussed so far, now we have come to the conclusion that the position of the front view is dependent on the position of the point with respect to the horizontal plane, and the distance of the front view of the point from the XY line is the same as the distance of the point from the horizontal plane. So that's end for this lecture. We will continue it in the coming lecture and the second part of it. So that's all for today. Thank you.